Hello my friends, today I would like to make a video to cover something I received recently, and just a random video. Before the video starts, I would like to let Mr. Louis Carson know that your mailbox is full. I had several chats with you about 1 week ago, and when I wanted to send you another reply on Wednesday, the system let me notice that your mailbox is full and I couldn't reach you. So in case you noticed this video, please let a comment down below to let me know from which way I can reach you to send you more just some schematics and some replies that's enough. Okay, and let's begin our video. First, I want to cover is about these special lamps which are used in fluorescent microscope. These lamps are actually HBO lamps. They are actually ultra high pressure mercury vapor bulbs. The glass bulb is made of quartz, so it is just for the UV radiation to penetrate it. And I have some pictures here. Here. These are the 12 HBO lamps I received about 1 week ago. This is a closer picture. This is an interesting picture. The first thing you will notice is that the left lamp has pre-matured. The second thing you notice is that the anode has a larger volume than the cathode. This is the same principle as in a short arc xenon lamp, because the electrons from the cathode to the anode will be accelerated by the electric field from the cathode to the anode, and when they reach the surface of the anode, their kinetic energy will be dissipated as heat. So the energy lost on the anode will be much larger than on the cathode. So it needs a larger thermal capacity, also a larger surface for better thermal conduction, and a larger surface for infrared radiation. That's a simple reason. Now you know it's a DC lamp, but it neither functions under the constant voltage mode nor under the constant voltage mode. It actually functions under constant power mode. For this kind of lamp, the rated power is 103 watts. This small lamp, 103 watts, not very big. The same bulb volume as in a projector. The bulb power can even reach up to 400 watts. So it's just not a very powerful one, but it's more powerful than a metal halide, the higher power density. For those who are interested in this kind of lamp, you can visit these optical corporations website, or you can get some information on the Osram Lighting website. The Zeiss Optical has some introduction about the HBO lamps in detail, and you can visit this website. It's a very interesting website. From this website, I know that about 90% of the light output is from the cathode spot. This spot, not the anode spot. And from this website, I know that when the arc is ignited and and the lamp is functioning, the inner pressure will reach up to around 75 ambient pressure. And when the light is off and cooled down, the inner pressure is lower, not much lower, just lower than the ambient pressure, just because they don't have the inner gas such as xenon, or they don't have the halogen because they need a clean spectrum, just mercury. So I mentioned that they don't have some halogen in there, so you can expect that it has a much shorter rated lifetime. For this lamp, the lifetime is around 200 hours. After 200 hours, the lamp will be something like this, blackened, right? Looks like a prematured metal halide, but this is just the lamp on which has aged just for 200 hours rated lifetime. Because I mentioned that it doesn't have the inner halogen gas. I believe that for those who are proficient in lamps or lightings, they know how the halogen functions in a quartz bulb. But here I will cover it just for those who are not proficient in lighting. Why did the lamp get blackened? Because the tungsten actually vaporized and condensed onto the colder part of the lamp, which stands for the quartz bulb around the electrodes. And when we add halogen into the bulb, the halogen will react with the condensed tungsten on the bulb, just because the temperature on the bulb is in the range that the halogen will act with the tungsten. But the halogen tungsten composed chemical is not very stable. Under extremely high temperature, like in the arc center, they will break down. They will break down and become halogen moleculars, and become tungsten particles. And the tungsten particles will condense onto the electrode because the breakdown happens in the arc or around the hotter arc. So actually the halogen gas brings the tungsten particles from the bulb to the electrode to increase the life, to prevent the premature. That's the simple function of the halogen in the bulb. When the light is blackened, the UV output will be decreased noticeably. For a 200 hours life, for a lamp which passed a 200 hours life, the output UV will decrease down to around 50% of the original output. But it is still very dangerous, because when I lighted one bulb several days ago, and of course I have welding masks on my face, but when I when my hand was around 20 centimeters from the light bulb, and I kept my hand there for about 10 seconds, and I smelled my hand. There's a very strange smell. The smell I haven't smelled in my life. It's very difficult to describe that. I will try it. I think it smells like 80% or 70% of the smell which you will smell under the sunlight, the old thing, the smell of the sunlight, and 20% of ozone and 10% of overbaked coffee beans. That is a very strange smell, unpleasant. So even a prematured lamp, the UV from these lamps are still very dangerous. Is still very dangerous. Sorry for the grammar fault. Since I don't have the original constant power source for the lamp, which I tried first when I received the bulb, was something like this. Let me get a paper. I connected the bulb, the HBO discharge bulb, right? In series is with a very large inductor, and in series with a post transformer, just for ignition. When the light is started, this coil just functions as a wire, and I connected this to a voltage source, just a switch mode power supply at 28 volts, no current limiting. This inductor here is function as a current stabilizer in just the same function in arc welder, but it can't limit the current, just stabilize the changing current, not a limiter like in a AC source. Remember, we have a DC source here. And when I initiated the arc, after 2 seconds, you guess what happened? Let me show you. This happened. Just 2 or 3 seconds later, the tungsten cathode melted to a ball. I even expected it would explode first, but the arc extinguished itself because the larger gap here and the stops here. So you can see if I use a constant voltage source to light a discharge lamp, this will happen. And let me show you. This is the same bulb. This is the same bulb. But when you look at it here, you see it's much clearer now. And the anode side, there are much more dark condensed tungsten here. So what happened next is that I don't want to waste this lamp. Oh, I need to mention first that these lamps cost around $140 each. $140 for a good bulb, but I chose a matured bulb to do this experiment. So please don't criticize me. I didn't waste one bulb. So what happened next is I used. I don't want to build some very some digital controlled constant power source just for lighting a bulb. I don't want to do that. I just want to know what this bulb looks like when it's working. So I just take out my ballast for a metal halide lamp to build a simple circuit. This is a starter, original starter, and the original metal halide lamp, original ballast, and the two bulbs in series. I need to mention that I measured the voltage across the metal halide lamp when only this metal halide is functioning. The voltage is 125 volts AC. And I connected the HBO lamp here, so it's working under AC power. So I just use this simple circuit and it worked. The voltage measured across the HBO lamp is 55 to 60 volts. I'm not sure whether it is due to the larger gap here than a good one. The good one I mentioned before, the voltage is in this range. I didn't know the change in the voltage from 20 to 25 to 55 to 60 volts is due to the larger gap between the electrodes, or is due to the AC arc property, because when the AC current cross 0 or the AC voltage cross 0, the arc extinguished, and the arc need to be initiated later when the sine wave gets to a higher than the normal operating voltage, and suddenly the voltage will be dropped. That is when the arc initiates. I didn't know the voltage rise in this circuit is due to which reason, but this circuit works, and the result is something like this. Sorry for the picture quality. This is a ballast, this is a metal halide, and this lamp on two insulators is the mercury vapor lamp. You see the strange fluorescent also here, violet light spot here. Those are due to the strong UV radiation. Also here, very strange color due to the UV radiation. That's a simple HBO experiment. If you want to do the similar experiment, please be careful with these bulbs, because it can explode and it can do harm to your skin or to your eyes if you don't protect yourselves safely. So be careful and enjoy the experiment. The next thing I want to mention is that let me find the picture. Okay, the next thing I wanted to mention is that my friend sent me these parts. You can guess what are these parts used for. I leave you 10 seconds to think about that. So these parts are actually used on diesel engines. From the channel's name, you may guess that I like the diesel engines, and actually my major in the university is about marine diesel engines. We learn how the diesel engines, the special kind of marine diesel engines, not the vehicle engines. We learn how the marine diesel engines functions and how to adjust them, and how to calculate some properties of the engine, the power output, and how to design the turbochargers or something else, some reheaters or anything else. We learn that. So I'm very interested in the marine diesel engines. My friend from Thai sent me these engine parts, which are used on a Japanese-made diesel engine called Daihatsu. Some of you may have heard a Ryuko patent as Daihatsu, but this company mainly builds the marine diesel engines. You see Daihatsu, the D is missing. And this is actually the fuel injector, which locates here. This is a fuel injector. This component, the fuel, high pressure fuel, actually enters this ring, and there are 3 holes here, and the holes all the way leading down to the needle valve, and the fuel will be sprayed out through a tiny hole. There are actually 8 spray holes, tiny spray holes here. And from this picture you can see the spray holes. On this nozzle there are 8. And this is the needle valve. The high pressure goes down to here and to this section. And the valve needle is loaded with a spring. And when the fuel pressure suddenly rises, the needle will be pushed to move upward, and the fuel will be sprayed out. Remember that the pressure here is several hundred ambient pressure. This is another kind of the spray nozzle. This is the same cross section as in this one. The difference is that the high pressure oil activates on this ring. This section is not used to withstand the high pressure oil. Because this surface may be polluted with some soot or carbon soot, right? I think you can understand that. So this surface in here, in this type of nozzle, is not designed to withstand the high pressure oil. This is a cross section of the 4-stroke diesel engine. And this is another interesting picture. Let me turn off the light. From here, you can see that the engine was made in 1981, May, and the rated power output is 4,000 horsepower, which represents to 3,000 kilowatts, and the revolution is 400 revolutions per hour. Made in Japan by Niigata Engine Workshop. 4-stroke diesel engines. Actually, I can see here is 8-cylinder, and the bore is 400 millimeters, and weighs to this is the weight 54.1 tons. This is the same engine. 4-stroke diesel engines, you can see, I just told you that it is a 8-cylinder engine. You can see here 1, 2, 3, 4, 5, 6, 7, 8, right? These are the doors for experimenting the crankshaft. there are 8 bearings, so 8 crankshaft doors here. These are 2, let me see. Oh, not 2. These are 1 turbocharger. This is the turbo side and this is the compressor side. Okay, turn on the light to get a better view. Many of you may be interested in that why my channel's name is something about diesel engines. Because I love anything which has a monster amount of power. You can feel it in my channel, because you can see I always do something dangerous and powerful components, right? I will graduate in 2024 July. I will graduate then, and I plan to work back with my relatives in Thai, Lem Chaban. That is the name of a local port, maybe to be a marine engineer. And we are still very young, so it's time for us to enjoy our youth. And I hope all of you can also enjoy your life. So I will keep on working and share something I do with you, my friends. So that's enough for today's video. Thanks for watching.